Nearly 200 earthquakes were recorded in Yellowstone National Park in just the past 2 weeks.
Things are about to get worse at Yellowstone National Park, and you know it's serious when it makes the world's richest man lose his sleep. Yellowstone National Park is a park known to be a breathtaking landscape of beautiful scenery. However, things are about to get ugly as something disturbing has recently surfaced. Following the prediction of more than 100 earthquakes, Elon Musk just warned about a fissure-crack being detected within the depths of the supervolcano beneath the park. What could have triggered this crack? Could the very forces that created this unique landscape also lead to its destruction?
This restless Yellowstone caldera is truly living, breathing, and every once in a while it burps.
Stay tuned to find out. Yellowstone National Park is the oldest, one of the largest, and perhaps the most renowned national park in the United States. Primarily located in northwestern Wyoming and partially extending into southern Montana and eastern Idaho, the park encompasses the highest concentration of hydrothermal features on the planet. Its establishment on March 1, 1872, marked the historic moment when Yellowstone was designated as the first inaugural national park in the country, offering everyone the opportunity to experience its exceptional hydrothermal and geologic wonders. However, Yellowstone National Park has been making the headlines recently, but unfortunately, not for positive reasons. A remarkable series of events has captured the spotlight, causing worry among scientists and the general public. Even though earthquakes are somewhat frequent in Yellowstone, making up about half of all the seismic activities in the Intermountain West of the country, these recent events have brought back talks and worries about a big earthquake happening in the national park. This place has a lot of earthquakes, around 800 to 3,000 every year, but most of them are small, and people don't notice. However, the recent group of shaking has caught people's interest. A recent information released in Discover magazine showed that observers in Grand Teton National Park, situated to the south of Yellowstone, have noted the gradual detachment of the cliff face at Hidden Falls and Inspiration. This phenomenon is attributed to the presence of cracks, or fissures, on the mountain. As these cracks emerge in close proximity to the Yellowstone caldera, several media outlets have drawn associations between them and the nearby volcano. However, it's essential to evaluate whether these speculations hold any validity. Is there a genuine indication of a potential eruption in the Yellowstone region? These conjectures have prompted billionaire Elon Musk to unveil a new revelation: the discovery of a substantial fissure deep within the supervolcano beneath Yellowstone Park. The critical question remains: could this possibly indicate an approaching eruption in the Yellowstone region? It is crucial to have a prior understanding of the region's volcanic and seismic activities to fully grasp the events that led to the recent unfolding of events and better grasp the degree of the impending danger. Let's discuss Yellowstone's volcanic timeline and geological factors linked with volcanic activity. The Yellowstone National Park's striking feature lies within a region that has experienced volcanic and seismic activity for tens of millions of years. The park sits directly atop a geological anomaly between the Earth's crust and mantle, known as a hotspot. In this context, a hotspot refers to a zone where molten rock or magma nears the surface, and as the name implies, a hotspot is constantly hot. This heat is generated from a plume of hot material that runs deep, sometimes into the core of the planet. This material rises, and this intense heat causes the crust to melt, generating magma that is fed into the magma chambers beneath the crust. This magma provides the heat for the beautiful geothermal features of the park, such as geysers and hot springs. Also, it could be the cause of Yellowstone National Park's destruction when it is compressed at certain pressures, leading to large and destructive volcanic eruptions. Although the science behind the formation and the reason for hotspots still eludes scientists' grasp to this day, several theories have been spun about their origins. The common postulate is that hotspots form over regions with ultra-high temperatures in the mantle. The movement of the North American plate has caused the Earth's crust in Yellowstone National Park to become thinner, sitting it directly over a hotspot. Roughly 2 million years ago, volcanic activity commenced in the Yellowstone National Park vicinity. This led to 3 massive eruptions, surpassing any documented eruptions in history, as molten magma surged deep within the Earth. The initial eruption, around 2.1 million years ago, formed a caldera. The forceful expulsion expelled enough magma to cause the land above it to cave in, creating an immense depression. The enormous crater, a caldera, spanned up to 80 kilometers in length and 65 kilometers in width. It reached depths of hundreds of meters and stretched beyond Yellowstone National Park's borders into its central region. Subsequently, the volcanic activity moved to a smaller zone in the Island Park region of eastern Idaho, southwest of Yellowstone National Park. This transition led to another significant eruption that formed a sizable caldera around 1.3 million years ago. The volcanic activity has been concentrated in the national park's vicinity. A massive eruption 631,000 years ago shaped the present-day Yellowstone caldera we observe today. In terms of magnitude, the 3 eruptions that resulted in caldera formation were approximately 6,000, 700, and 2,500 times more powerful than the eruption of Mount St. Helens in Washington on May 18, 1980. Collectively, these 3 eruptions released sufficient ash and lava to fill the Grand Canyon. Over the past eons of years, volcanic activity has given rise to some landmarks in Yellowstone National Park. A noteworthy one is the Yellowstone caldera, often called the Yellowstone supervolcano. It's a huge volcanic pot in the west of the park, occupying a significant landmass with a dimension that stretches approximately 30 by 45 miles, 50 by 70 kilometers. Most of it sits in the northwestern part of Wyoming. The Yellowstone caldera is a result of the most recent volcanic activity in the area, formed around 600,000 years ago. The Yellowstone caldera is a massive crater from a catastrophic volcanic eruption around 640,000 years ago. About 2.1 million years ago, the first caldera eruption rocked the area, and then, nearly 800,000 years later, the second eruption unfolded. In July 2023, scientists mapped the magma chamber beneath the Yellowstone supervolcano, revealing that it is mostly mush and contains more molten rock than previously estimated. While there are no signs of an imminent eruption, researchers are monitoring the ground for any signs of rising, which could indicate the start of a mega-eruption. Do these repeating earthquakes suggest that a volcanic eruption might happen soon because the underground magma reservoirs are being refilled? Let's look at the timeline of seismic activities in Yellowstone. Beneath the park is a network of faults linked to its volcanic past that also exposes the region to its numerous encounters of minor earthquakes annually. The underground network of hot water and magma beneath Yellowstone is impacted by the same forces that trigger earthquakes. The most significant historical earthquake in the Rocky Mountains happened within the Yellowstone area. Most of these earthquakes are of magnitude 2.0 or lower, going unnoticed by nearby people. However, a stronger quake sometimes occurs in the area, impacting the park. An example is the 1959 deadly quake in southern Montana, near the park's northwest corner, which affected several hydrothermal features in Yellowstone, including the famous geyser Old Faithful. Around 3,000 years ago, a significant explosion occurred due to the triggering of landslides. The occurrence of landslides is a major concern in this area. Due to the region's unstable terrain, weathering and earthquakes can trigger sudden and rapid landslides, obstructing roads and trails. This poses a risk to both hikers and drivers, as the tremors and earthquakes can also alter geysers and hot springs, potentially exacerbating landslide occurrences. Just like in previous years, attention has been drawn to the monitoring data gathered throughout the year. To give you an idea, in 2022 alone, the Yellowstone area experienced 2,429 earthquakes. Among them, a notable standout was a magnitude 4.2 quake on May 11th. This passes as the mightiest tremor the region has seen since a magnitude 4.4 shake in 2017. Yellowstone experienced significant precipitation in 2022, particularly in mid-June, when an atmospheric river event brought heavy rain onto the late-season snowpack. This resulted in severe flooding across the Yellowstone area, prompting the temporary closure of the entire park. Due to the flood damage, the north and northeast entrance roads remained inaccessible for the summer. Meanwhile, the number of earthquakes in 2022 is pretty normal, and a bit fewer than in 2021. Interestingly, about 66% of these earthquakes happened in swarms, which means they were bunched together both where and when they occurred. The standout swarm was notable, with more than 1,100 earthquakes, and it persisted throughout the latter half of the year. This swarm occurred close to Grizzly Lake, between Mammoth Hot Springs and Norris Geyser Basin. It's worth mentioning that earthquake swarms of this scale, with hundreds to even thousands of events lasting for several months, are common in Yellowstone and tend to happen every few years. A series of earthquakes were also detected beneath the northern part of Yellowstone Lake. Seismologists are closely monitoring the seismic activity within Yellowstone National Park. The University of Utah's seismographs recorded this sequence of earthquakes, which began on March 28th with a minor quake, measuring 0.7 in magnitude around 11 p.m. MDT. Within 12 hours, 60 earthquakes ranging from magnitudes 0.1 to 3.7 were observed. While ongoing analysis is being conducted to assess additional minor tremors in the area, the University of Utah emphasized that 2 quakes surpassed the 3.0 magnitude threshold. One was recorded at 3.1 magnitude at 7:05 a.m. MDT, and the other registered a magnitude of 3.7 at 8:24 a.m. MDT. Although the recent series of earthquakes might raise some worries, it is crucial to remember that they fall within the typical range of seismic activity for the Yellowstone region. The monitoring and analysis of these patterns play a key role in comprehending the geological processes in the area and can enhance disaster readiness efforts. According to the United States Geological Survey, sometimes a few big earthquakes in a region bigger than magnitude 6 are thought to be connected to either a later volcanic eruption or some kind of disturbance at a nearby volcano. Yet volcanoes can only be triggered to erupt by earthquakes caused by the movement of nearby tectonic plates if the volcanoes were already ready to erupt. This needs 2 things to be true. There must be enough magma in the volcano to erupt. There must be high pressure in the area where the magma is stored. If these 2 things are there, then it's possible that the strong tectonic earthquakes could make gases trapped in the magma, like gas in a shaken soda bottle, come out. This might increase the pressure and could even lead to an eruption. Let us look at Elon Musk's warning about the Yellowstone supervolcano. The Yellowstone Volcano Observatory explained that the EarthScope Consortium manages a network of GPS, borehole strain meter, and seismometer instruments within the park. These instruments are crucial in monitoring earthquake, volcanic, and hydrothermal activity in the Yellowstone region, relying on a robust communications network to ensure continuous data streaming. The monitoring stations at Yellowstone face limitations with radio and cellular communication methods. For instance, cellular service might experience slowdowns during busy tourist periods. In contrast, satellite-based solutions like Starlink don't share this vulnerability, performing consistently as long as they have an unobstructed view of the sky. Considering this, Starlink is currently undergoing testing to reduce reliance on cellular networks in the park. In May, a Starlink system was established between Mammoth Hot Springs and Norris Geyser Basin at a borehole station. Initial tests have shown promising results for the system's performance. Suppose these tests continue to yield positive outcomes. In that case, additional Starlink satellite internet systems will probably be introduced before winter. This is particularly crucial due to the challenging accessibility of remote areas surrounding Yellowstone during harsh weather conditions. With a network comprising over 4,000 satellites, Starlink stands as the world's largest satellite system. Through their expansive satellite system, Starlink has taken on the task of keeping a vigilant watch over the park's geological events. This endeavor is important as it contributes to a deeper understanding of the complex underground processes and phenomena that shape the park's landscape. By utilizing their advanced satellite technology, Starlink provides scientists with valuable insights into the movement of the Earth's crust and the behavior of volcanoes. The findings from the region's monitoring led to Elon Musk's recent tweet, which highlighted a significant dome-shaped uplift in Yellowstone National Park. This phenomenon is associated with a supervolcano, and the potential consequences of its eruption could lead to widespread devastation on a planetary scale. Magma from Yellowstone flows into a reservoir 6 to 10 kilometers beneath the park. This influx has led to the park's ground swelling, resulting in a dome-shaped uplift. Scientists have monitored the volcano's activity since 1923, observing gradual ground bulging without worry. Nevertheless, in 2004, there was an abrupt subsidence of the land, followed by a significant rise of about 25 centimeters over the subsequent 5 years, raising a substantial alarm. Seismologists and geologists are still meticulously analyzing the data, looking for patterns and indications that could signal shifts in the behavior of the volcanic system. The University of Utah seismograph stations and the Yellowstone Volcano Observatory have reassured the public, stating that the recent rise in the land does not indicate an imminent volcanic eruption. The partnership between Starlink and the scientific community exemplifies the potential benefits of collaboration between the private sector and researchers. While ongoing enhancements to the system and the continuous launch of new Starlink satellites are expected to further improve its capabilities over time, Elon Musk deserves commendation for his remarkable involvement in closely monitoring the seismic and volcanic activities occurring within Yellowstone National Park. When is the next supervolcanic eruption occurring? The recent succession of earthquakes near the eastern edge of the Yellowstone caldera, near the location of the major previous eruption, has drawn renewed interest to this geological wonder. There has been a pressing question of whether the supervolcano is exhibiting signs of reawakening, or if the recent tremors are merely nature's way of reminding us of its ever-present and unpredictable might. People are now wondering if these events could potentially indicate the possibility of a larger eruption ahead. The potential eruption of the volcano beneath Yellowstone National Park carries an immense threat that is difficult to quantify. Its potential devastation could be of such magnitude that it would leave an unforgettable impact on human history. Recent research has revealed a startling revelation. Contrary to previous beliefs, there are not just one but two reservoirs of molten rock beneath the colossal volcano. The initial reservoir, discovered in the 1980s, lies approximately 10 kilometers beneath the surface and holds around 10,000 cubic kilometers of melted material. However, the discovery of a second magma reservoir at depths ranging from 20 to 50 kilometers below is even more significant. This second reservoir is a remarkable 4.5 times larger than the first. Seismic technology led to the identification of this deeper reservoir, marking a groundbreaking advancement. These reservoirs contain enough molten rock to fill the Grand Canyon nearly 14 times over. The next eruption at Yellowstone could shoot out about 240 cubic miles of magma. This might cause a volcanic winter that lasts for 10 years and even make a crater spanning several states. So yes, it's a huge volcano, and we all hope it doesn't erupt in our lifetime. If a big volcanic eruption like the ones that form craters were to happen at Yellowstone, its effects would reach all over the world. This huge eruption would cause things like ash falling and changes in the world's weather for a few years to a few decades. The areas closest to Yellowstone in Montana, Idaho, and Wyoming would experience pyroclastic flows, and other parts of the United States would be affected by ash falling from the eruption. Usually, these kinds of eruptions create calderas. They form when the ground collapses due to the magma beneath moving away. Luckily, the chances of this type of eruption happening at Yellowstone in the next few thousand years are extremely low. The biggest harm would come from the volcanic ash, a mix of shattered rock and glass. A major eruption could propel thousands of cubic kilometers of ash into the atmosphere, blanketing parts of North America. As shown on a map, places as far away as Missouri and Texas might end up covered with over 10 centimeters of ash. Meanwhile, areas closer to Yellowstone could be buried under several meters of ash. The effect on people would also be extremely severe. The park and the areas close by are visited by millions of tourists annually. Towns and communities nearby would be at high risk, and it would be difficult to ensure everyone's safety. According to one estimation, a super eruption at Yellowstone could impact about 3/4 of the United States, and almost everyone within 1,000 kilometers of the blast might not survive. Plants and animals would be affected, and buildings would even be crushed. The destruction of property would result in losses amounting to trillions of dollars, and even the most powerful nation would experience darkness as electrical grids fail. Such massive volcanic eruptions would significantly impact the world's climate, causing cooling and harming crops globally. This could potentially trigger food shortages in certain regions. Fortunately, the Yellowstone supervolcano is one of the most closely watched globally. Popular scientific opinion states that there is no sign of an eruption happening, at least not soon. We would probably have several weeks, months, or even years of warning before the next eruption at Yellowstone. In a recent Journal of Geophysical Research publication, scientists have introduced a game-changing method for closely tracking volcanic activity. This innovative approach combines satellite technology and machine learning algorithms to detect subtle ground movements related to volcanic processes. The study, centered around Yellowstone's supervolcano, highlights the technique's capability to measure minute ground shifts caused by magma movement and other geological forces. By utilizing satellite radar data and advanced machine learning, researchers can differentiate between various types of ground motion, offering insights into magma behavior. This advancement holds great promise, potentially enabling earlier detection and prediction of volcanic events. Unlike conventional methods that rely on seismic data and surface observations, this approach could provide crucial lead time, weeks to months, before volcanic activity escalates. Beyond Yellowstone, this breakthrough sets a precedent for global volcano monitoring. By enhancing our ability to decipher signs of volcanic unrest, this collaboration between technology and science could revolutionize hazard assessment and disaster preparedness strategies, providing crucial insights into Earth's geological processes. Thanks for watching. Don't miss this video you see on your screen right now. It's unbelievable.